Hello students, this is Miss Dalton and this video is over the properties of exponents. Here are the different properties of exponents that we're going to look at in this video. You were first introduced to these properties probably back in Algebra 1. We have the first one that's called the product property, and basically what that means is if you have two numbers or variables that are being multiplied exponentially, so when we say exponentially, they both have exponents. We multiply exponentially. If they have the same base, then you will keep your base, but what you will do with the exponents is you will add them. So you'll take the m and the n and you add them to m plus n. The quotient property is when you're dividing exponentially. If the bases are the same, you'll keep your base, and then you'll just subtract your exponents. So you'll have the m minus n. Power of a power property, this is when you have an exponent being raised to another exponent, and so in that case, you would multiply the exponents. The negative exponent, anytime you have a negative exponent, what that does is it has you flip the base. So it's going to make the base, or turn the base into the reciprocal of the base. So in this particular one, we have a to the negative m, meaning I will make the reciprocal of a being 1 over a, and then you'll just raise it to the m power. So all the negative exponent does, the negative just makes you flip it. Zero exponent, anything to the 0 power is equal to 1. It doesn't matter what you have. You could have, 10,000 to the 0 power, and it's still equal to 1. So anything to the 0 power is equal to 1. The power of a product, this combines a couple. You just want to make sure that you distribute that power to both of your bases. So I'll have a to the m times b to the m. Power of a quotient, same thing. Make sure that you bring that exponent to both the numerator and the denominator. So you'll have a to the m over b to the m. So if we look at a couple of examples for the product property, here we have negative 5 to the 4th times negative 5 to the 5th. So we can see that we have the same base. You'll keep your base, but now we'll just add those exponents. So it'll be negative 5 to the 9th. Now I'm going to keep the negative in parentheses because it was in parentheses up here. And then the only other thing that I could do is say, well, that's also equal to negative 5 to the 9th. Anytime you have an odd power, it's going to stay a negative. And so having that odd power of 9, it would be the same thing as not using parentheses. Because remember that when you're using parentheses, that 9 exponent is going to go to both the negative, or to the negative 5. But when I have it here, that 9 is only going to go to the 5, and then it's going to make it negative. So again, in this particular case, they're the same thing. So you, because of the odd exponent. If it was an even exponent, then it would turn to a positive. Here we have x to the 5th times x squared. So again, our bases are the same. So you would just add those exponents. So x to the 7th. Power of a power. So just remember, power of a power you multiply. So you would keep your base of 2, and I would multiply the 3 times 4. So that would be 2 to the 12th power. Oh, sorry. Let me do that again. That looks better. Okay, the second example, n to the 4th to the 5th. So we'll keep the n, but then the 4 gets multiplied times the 5, so it'd be n to the 20th. All right, so let's look at some examples for the negative exponent. In this first example, we have negative 5 to the negative 6 times negative 5 to the fourth. So the first thing you would want to use your product property, which means that you add those exponents. So you'd have negative 5 to the negative 6 plus 4, which would be negative 2. And then you don't ever want to leave a negative in your answer, negative exponent in your answer. And so now we need to take that negative exponent, and what that does is it will flip your base. So now it's going to be 1 over negative 5, and then we're going to raise it to the positive 2. Now 1 to the second will just stay 1. But then if I take negative 5 to the second power, that's negative 5 times negative 5, that's going to give you 25. So simplified, it would be 1 over 25. In the next example, 2/3 to the negative 3. So because we have that negative power, that's going to make us flip our base. So it's going to become 3 over 2 now. And it's going to get raised to the power of positive 3. So here, you'd want to make sure that you bring that to both. So 3 to the third is 27 over 2 to the third, which is 8. Okay, next example. We have x over y to the negative 5, and that's being raised up to the second power. When you have an exponent on the outside, you want to make sure that you distribute it to both pieces. So I have x squared over, and then this would be a power to a power, so you multiply, that would be y to the negative 10th. Now you don't want to leave your answer with a negative exponent, so you now need to flip that up to the top. So anytime a negative exponent is in the denominator, that just flips it up to the numerator. So you'll still have the x squared in the numerator, but now the y to the positive 10 will come up and join it. So that would be your final answer. All right, last couple of examples combines a couple of different properties. So let's look at this first one. The first thing I'd want to do is I'd want to distribute that power of 2 to both pieces in the parentheses. So that's going to be 7 squared, and then we need to multiply those exponents, so b to the negative 6, and I'll go ahead and do what 7 squared is in just a second. And then I have b to the 5th times b. So then just simplify it. 7 squared is 49. Now, since all of these have a base of b, then I would just add my exponents. But remember, b with no exponent has an understood 1 there. So if you add all those together, negative 6 plus 5 plus 1, that gives you b to the 0 power. But what happens when you have anything to the 0 power? That equals 1. So this would be equal to 1, and 49 times 1 is just 49. So that's your answer. So this combines a couple of different properties into one. In the second example, you have x to the 5th divided by x to the 10th. The property tells you to subtract those exponents, x to the 5th minus 10, which would give you x to the negative 5, but you can't have a negative exponent in your answer, so that's going to make you flip it and be 1 over x to the 5. Now, let me show you a little bit of a shortcut here. What I do here when I am dividing exponents, I'll look and see, I want to think about this in expanded form. X to the 5th is the same thing as x times x times x times x times x. X to the 10th is x, 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 x. And so anytime you have expanded form, you can look for things that cancel. Okay, well, what I have here is I have 5 x's that cancel. Now, where are my leftover x's? Well, they're in the denominator. I don't have any left on top, so I always have to mark that with a 1. But on the bottom, I do have x to the 5th left over. So if you think about this in expanded form like that, it kind of is a little bit of a shortcut, because you just want to see, where do I have more x's? I have more x's in the denominator. How many more? I have 5 more. So in my answer, I should have x to the 5th in the denominator, and nothing's left in the top, and so you just leave it as 1. All right, hopefully this was a little bit of a review for you, because it is something that you saw in Algebra 1. But come to class with any questions that you have, and we'll make sure we go over those.